today's class. But today we're studying on the inverse trigonometric function of differentiation, right? The inverse trigonometric function of differentiation. Alright, given that y is equal to sine inverse of x, given that y is equal to sine inverse of x, given that y is equal to sine inverse of x, of course, the y over the x, the y over the x is equal to 1 over root 1 minus x squared. Given that y is equal to sine inverse of x, the y over the x is equal to 1 all over root 1 minus x squared. So the fact says that if you are given that y is equal to sine inverse of something, or perhaps sine inverse of x, so note that the y over x is what? 1 over root 1 minus x squared. Proof. 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 Alright. Look up. Let me try this along. Listen. Help me punch sine 50 all squared plus cos 50 all squared. Please give me an answer, please. If I punch sine 50 all squared, positive cos 50 all squared, what will be the answer? Of course, the answer there what? Will be 1. I'll have 1 as the answer. So try to punch it. Sine 50, who's in the bracket? Bracket, sine 50, put the bracket all squared, positive cos 50 all squared. Of course, my answer there will be 1. So what do we mean? Listen. If I have sine of something all squared, positive cos of that same thing all squared, of course, our answer will be 1. So in this case now, I can express it as saying, now listen, sine 50 squared simply means sine squared 50. I'm still saying the same language. Of course, plus cos squared 50 is still same as cos 50 squared, being equal to what? Different in expression. They are the same thing. Now we said sine square of something plus cos square of that same thing. I'll have got a 1 as my answer. I can also recall from a popular trig function that says that sine square theta, right, plus square theta is equal to 1. This is a popular trig function which is still correct. Cos and cos, 50 and 50, I will have 1. So the idea is that sine square of something, positive cos square of that same thing, I will have 1 as my answer. Right? So from here, I can infer that sine squared of y, positive cos squared of y is equal to 1. Right? I'm just saying the same thing. Of course, from here, let's make sine square y solid number. So I'll have that sine squared y is equal to 1. Take this man here, negative cos squared y. Of course, this square comes and becomes square root. I'll have that sine y is equal to a square root of 1 minus cos squared y. Right? So I'll make sine y the subject. Next task, make cos y the subject. Simple. Just say cos y is equal to square root of 1 minus sine squared y. So for cos y, I'll have sine squared y. For sine y, I'll have cos squared y. So I need these two stuff in our proving. So we need these two one here in our proving. Alright. Listen. It's quite simple, right? What we're just trying to say is that just said y is equal to sine inverse of x. Of course, if I say sine inverse, if I have a is equal to minus 1 is equal to what? 1 over a from the concept of indices. Apply this concept here. I'll have that y is equal to 1 over sine x. I have that y is equal to 1 over sine x. Right? Of course, from this place here, I can multiply y times sine x. I will have what? Sine y is equal to sine x times y is what? Sine y is equal to 1 times 1 because of them. I'll have 1. I'll have 1. Right? I'll have 1. So at this point, what do you do here? So we said, okay. Alright, listen. Sine inverse alone is 1 over sine. X will be somewhere here. Right? X will stand alone. Sine inverse, if I have A inverse 1 over A, of course, sine inverse 1 over sine. This S is here. Of course, 1 times X is X. Right? So 1 times X is still X. So I can have X here. I can have X here. Of course, X times 1 is what? X. I'll have X here. Y times sine is what? Sine Y. Sine times Y. Sine Y will equal to 1 times X is what? X. At this point, I will differentiate left hand side using implicit concept. And I will differentiate this man here using general method. Of course, if I replace sine X, I'll have if I replace sine Y, I'll have what then? Cos Y into the Y over the X. We said apply implicit concept. So if equal to, if I replace X, I'll have 1. Right? I'll have 1. Our fact says that Y is equal to sine inverse of X. No problem. Sine inverse can be written as what? 1 over sine X. Of course, X times 1 will give us X over sine. Now at this point, I'll multiply. I'll have that sine times Y is sine Y will equal to 1 times X is what? X. At this point, differentiate this man here using implicit concept. And this man using what? General method. Of course, if I replace sine Y, I'll have what then? I'll have cos Y. Then attach what? The Y over the X to it will equal to 1. At this point, divide through by cos Y. So, divide by cos Y. Of course, I'll have cos Y into the Y by the X over cos Y is equal to 1 over what there? Cos Y. At this point, this man cancels this. I'm left with what? The Y over the X is equal to 1 over cos Y. But we just said cos Y to what there? Root 1 minus x squared, sine squared Y. That's root 1 minus sine squared Y. Of course, put this one here. I'll have that the Y over the X is equal to 1 all over, I'm saying cos Y, which is equal to what? Cos Y is equal to this man here. That's this man. That's root 1 minus sine squared Y. But sine Y, what was sine Y? Sine Y was what? Sine Y was X. That's X. So hence, I'll put X here. I'll have that the Y over the X is equal to 1 all over root 1 minus sine squared Y. Sine Y is X. What of this square? I have my square. This is like the that if I have y equals sin inverse of x, the y over the x is what? 1 over root 1 minus x squared. So proved. 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 Alright, let's discuss the second part. Right? Alright, given that y is equal to cos inverse of x, given that y is equal to cos inverse of x, given that y is equal to cos inverse of x, given that y is equal to cos inverse of x, the divided by the x over the x is equal to minus 1 all over root 1 minus x squared. Given that y is equal to cos inverse of x, divided by the x is equal to negative 1 all over root 1 minus x squared. The difference between the first one and this one was that for the first one, there is no negative up here, right? So when it comes to cos inverse of x, always put negative up here, right? Sin inverse of x they don't have negative, but they are the same, right? So you should know the difference between sin inverse of x and what the cos inverse of x. So given that y is equal to cos inverse of x, divided by the x is equal to negative 1 all over root 1 minus x squared. Proof. Proof. Alright. So proof this concept is quite similar with the first one we did. How do you prove this? We said y is equal to cos inverse of x of x. Of course, for cos inverse, I'll have that y is equal to 1 over cos. For cos inverse, 1 over cos. Into what then? Into this x. 1 times x becomes x. I'll have that y is equal to x over cos. Of course, at this point, cross multiply. Cos times y becomes cos y is equal to, in this one here, 1 times x becomes x. At this point, I'll differentiate left hand side using implicit concept. Differentiate right hand side using what the general method. Of course, if I differentiate cos y, I'll have what the minus sin y into dy by the x is equal to differentiate x, I'll have 1. At this point, divide both sides by minus sin y. So divide by minus sin y. I'll have that minus sin y into the y by the x over minus sin y is equal to 1 all over minus sin y. Of course, this man cancel out this man. I'm left with what? The y over the x. In mathematics, it is not correct to put negative as denominator. So shift it here as numerator. I'll have that negative 1 all over sin y. Of course, we just said that sin y should be what? Root 1 minus cos squared y. We said this earlier. But y is equal to what? Sorry, but sin y is equal to root 1 minus cos squared y, right? Sin y is equal to root 1 minus cos squared y. Of course, I'll have that the y over the x is now equal in value to negative 1 minus 1 all over, let's say this, sin y was now root 1 minus cos squared y. That becomes root I have that y is equal to cos inverse of x, cos inverse of x divided by x what? Minus 1 all over root 1 minus x squared. This is proving to this man. Alright, let's prove the last concept, tan inverse of x. We just prove the sine inverse of x and now cos inverse of x. Let's prove for tan inverse of x. Alright, given that y is equal to tan inverse of x, given that y is equal to tan inverse of x, given that y is equal to tan inverse of x, the y over the x, the y over the x is equal to 1 all over 1 plus x squared. Proof. Given that y is equal to tan inverse of x, the y over the x is equal to 1 over root 1 plus x squared. No? 1 plus x squared. Have it. Given that y is equal to tan inverse of x, the y over x is equal to 1 all over 1 plus x squared. Proof this one. Alright, let's do this one here. Now, to prove this concept, recall from my popular trig functions. Recall from what popular trig function that says that if I have 1 plus tan squared x, tan squared x is equal to what is sec squared x. Recall this trig function that 1 plus tan squared x is equal to sec squared x. Alright, at this point here, listen. At this point, let's put this one here. I have that y is equal to tan inverse of x. Of course, for tan inverse, what do you know? Y is equal to 1 over tan, then what? X. 1 times x becomes x. I have that y is equal to x all over tan. Of course, at this point, cross multiply, I'll have that tan times y becomes tan y is equal to x. Differentiate this man using what the implicit concept. Differentiate this man using what the general method. Of course, for this one, if I relate tan y, I'll have sec squared y into what? The y over the x. I'm done with this. Is equal to, if I replace sign, if I replace x, I have 1. At this point, divide by sec squared y divided by sec squared y. I have this man, after this man, I'm left with what? The y over the x is equal to 1 all over sec squared y. 1 all over sec squared y. Now listen. I can say that, listen, 1 plus tan squared y is equal to sec squared y. I'm still correct. 1 plus tan squared x is equal to sec squared x. If that is true, if I have sec squared y, for instance, is equal to what? 1 plus tan squared y. But from this